Good morning. Can you hear me? I'm not used to talk, through microphone. My name is Rong Yang, and I'm teaching in computer science at Western Kentucky University, United States. And my co-author, Leyla, and she couldn't be here, so I'm here to share our work and hopefully get some, feedback from you guys. See, one of the main purposes of learning analytics is to provide us with some useful insights into the process by which learners master their subjects. Therefore, we can provide some, helpful information, such as to streamline and optimize the learning experience. Today, Cyberlearners have access to a great deal amount of learning resources because of the increase of the open source platforms. At the same time, such increase has caused difficulties for learners to be able to get hands on the information they're looking for or appropriate material they're looking for effectively. This open source platforms has provided us a good opportunity to study in detail about the interactions between the learners and the system so that we can dynamically help them to improve their experience. For example, in the United States, there are quite a few very popular open source platforms, like the one on the right hand, the second one, that's from MIT, is called OpenCourseWare. I believe it offers more than 2,000 courses, online. The third one over here provides a similar kind of learning resource by Harvard University Library. Also, the Stanford has online courses, is free to the public in artificial intelligence and machine learning. At Western Kentucky University, we have an open source platform called Hypermedia. So we, operate it as a HMM. So that's the first one. Our research was set out to try to answer the following few questions. The first question is that how can we detect a community of similar cyberlearners based on the structure of a huge social network? The second question is how can we present this interconnection among the communities visually to analyze cyberlearners' behavior? And the last question is how can we apply our results to build a community-based recommender or recommendation system? Our research is based on the WKU's Hypermedia I mentioned earlier, which has been in active use for about 6 and 7 years. We mined the log file of the system, and in our research in trying to analyze the learner's behavior. And here are some kind of features about the platform. So it's an open source educational resources that are trying to provide the materials for our client from any place at any time, and hopefully in many ways. We use state-of-art data mining algorithms and provide the web services to deliver also the learning resources in different kind of formats through the Web 3.0. So, you know, the Web 3.0 is more like the people and the machine are helping each other out. It's not just the interaction between people and people anymore. Just like, you know, some of the speakers has mentioned early, when you trying to search for books on Amazon, and the machine is trying to help you and say, hey, somebody has, you know, looked up this book before, has purchased this book before, also has bought those. So it's kind of make it more efficient to help you find what you need from that website. This platform also provide all different kind of searchable content. You know, we have a metadata search, semantic search, and also visualized and then cross-language searchable content. And also we provide a semantic recommender system. Well, this many resources are arranged in a hierarchy, you know, manner to help our learners to zero in on the topics that they are interested in. You know, for example, we started with, you know, colleges, 14 colleges at our school. And then for each colleges, and then we arrange, you know, there are different courses offered by different colleges. And then, you know, within each course, and we have different resources. And the resources can be delivered in different kind of format, like audio, video, lecture, and podcast or vodcast. And the total right now is more than, you know, 10,000 objects that are available over HMM platform. We have discovered that the majority of our learners prefer to use the visual interface. If you look at this statistics pie here, it's almost 60% of them using the visual interface. Well, this is great, but it raises questions. First of all, are there any limits? In other words, is our cognitive system able to deal with such a vast amount of resources? And second question is that, are cyber learners able to find what they really want? In other words, are they successful? Okay, you probably have heard of this, they call it short-term memory, which was discovered by George Miller in one of his famous papers. Do you guys remember the name of the paper? No? I don't remember the name exactly, but but basically is to discover that we can remember pretty much from 5 to 9 things. Okay, so this is called a magic number, 7 plus minus 2. So this is a short-term memory. So what that means is that a learner may easily become overloaded if we try to provide them too many pieces of disjoint information. And right now, we are providing our cyber learners with a semantic recommendation system, so which will give them the related search. But this may not be enough because of this short-term memory fails. So now we're trying to, ask ourselves, can we help our cyber learners to remember those learning resources by linking or relating them conceptually to other resources? Okay, so in other words, we are looking for more focused help to our client. So with the goal of a recommender system in mind, we decided to look for good recommendations from the users of our open source platform who were similar to our client. So this means that we need to develop a good understanding of the communities, of the commonality on this hypermedia system. So how can we find the communities based on the following category? For example, they share common learning domains. Okay, they're from different colleges and they are taking the similar courses, or they have similar problems or interests, and also, have similar learning styles. Well, this is quite challenging because the system has thousands of resources and also have hundreds of thousands of Cyberlearners. By far we have about 750,000, learners. Okay, so we wanted to be able to find a community detection methods which assume no pre-knowledge, so we call it bottom-up. And also, it was data-driven and based on archive of this platform over the last 6-7 years. We go ahead and then just use the 6 months period of a log file and then turn it into a graph. In this graph, vertices represent users and learning resources, and the edges connect users to the resources they use, and weighted by the number of interactions, similar to the idea Dan has mentioned earlier. So after a great deal of texting, and we choose the network visualization to initially detect the community candidates. And then we go ahead and apply the network analysis modularity to actually select the best of those community decompositions. And here's the graph. And this graph over here represents the social network structure of a weblog from February to August last year. So it has 8,000 nodes and 24,000 edges. And we wanted to simplify the actual situation somewhat. So this learning resource interaction graph has about 10 communities of learners based on their commonality. And we assume that the communities are all the same size. Well, even if they're not, it doesn't affect the argument we're trying to make here. So a client belongs to one of those communities, right? So therefore, instead of originally being one of the learners among 80,000 learners, and so now he can be or she can be considered as a learner among 800 learners. But still a huge number, 800, right? So if this learner needs a recommendation, he doesn't want to receive the help from those 800 people in the learning community. So we need to do more work. So we need to look at the graph carefully. Each Cyberlearner has a unique distance from a resource he uses. That's the weights. So a dot ahead of him is another learner who is more experienced, who has visited that resource more often. And a dot behind is a learner who is less experienced. So a learner very close to the resource could be considered as an expert. So now we were asking, do we want to intimidate our learner with an expert, or do we just go ahead and provide them some information from the client who is closer to him or closest to him? Our answer is neither one. What we did is kind of apply the chunking hypothesis to improve the learning experience. Actually, we have used this kind of hypothesis in our daily life, like telephone numbers. They're 10 digits. We hardly memorize them, right? But we kind of divide them up into area code and all that, so it's easier for us to remember. So we combine those two ideas I just mentioned, STM and then chunking, so that we're trying to recommend the resources the learner has not visited before from his closest 3 neighbors, which is triangle, and also, not over 5 to 9. So we illustrate the process visually by using this social network graph. You can see here, those big dots represents the resources, and those smaller ones are learners. And if we blow up a little bit, and you can see that the big, yellow ball, that's a ball, that's the learning resource, and the 3 learners are trying to provide help to the client, and then for this particular resource. So our plan in the future is to implement our triangle-based recommender system within our platform, and also go ahead and provide some kind of feedback based on the user feedback. Okay, thank you very much.
Thank you as well, and we have time for some questions. Yes, please.
Because when we're trying to find is either like a triad, or it's a triad, so it's just 3 in the community.
Yes.
Another question? Yeah.
I'm wondering about whether you're empirically checking out this 7 plus or minus 2 thing, because those were studies of what we can retain in a rehearsal loop in our mind, but with rich visualization interfaces, I think people can deal with more than 7 pieces of information, because we rely on external artifacts to extend our capabilities. So I just say be careful about using that as a justification unless you actually have empirical studies showing that that limit applies in your setting for the reason I just gave.
I think we're just trying to limit the amount of information that we recommend to our client. So that's just provide some kind of theoretical base, I guess.
Yeah. I've seen this theoretical base, this line of empirical work kind of overused as saying we can never deal with more than 7 things, but we can if they're externalized in a nice way. And I'm interested in following your work, by the way. I just wanted to give you that suggestion.